5.3, we're going to look at graphing rational functions. So we looked at a rational function f of x as being m of x divided by n of x. And we had looked at functions where m of x and n of x are polynomial functions and the denominator is not equal to 0. But what if the numerator and denominator were linear functions of the form ax plus b divided by cx plus d? Those are the kind of functions we are going to graph in this lesson. And what we're going to do is when we find that the numerator and denominator are linear functions, then we can rewrite them by doing long division. So if you remember, when you do long division, we will get, the dividend is equal to the quotient times divisor plus remainder. So if I were to give you an example, let's say if you were dividing 7 divided by 3, so you do 7 divided by 3, 3 twos are 6, 7 minus 6 is 1. So you would say that the 7, this is the dividend, 3 is the divisor, 2 is the quotient, and 1 is the remainder. So we would say 7 is equal to 2, which is the quotient, times the 3, which is the divisor, plus the remainder, which is 1. So 2 times 3 is 6, plus 1 is 7. So that's what this means. We're going to use that same relationship and write down the function using that relationship. So we're going to perform long division for these cases, and we'll start off with an investigation of this function, f of x equals x plus 1 divided by x minus 2. And as you can see, the numerator and the denominator are linear functions. And we're going to find out some characteristics about it before we sketch it. And we're going to do what are the x and y intercepts. We're going to kind of see if there are any vertical or horizontal asymptotes and what they are, and what intervals the function is positive and negative, and what are the intervals of increase and decrease. And then we can use all that information to graph the function. Okay, so we're going to, this has to be rewritten using long division. So let's do that over here. We're going to divide x plus 1 by x minus 2. So x goes into x one time. X times 1 is x, and 1 times negative 2 is negative 2. You subtract, and you get a remainder of 3. So you can rewrite f of x as f of x equals one times x minus 2 plus 3. So that is the dividend. So that's this part here divided by x minus 2. We're going to split this up. So this will be x minus 2 divided by x minus 2, which is 1, plus 3 divided by x minus 2, which is 3 over x minus 2. So this is the way we're going to rewrite the function. And the advantage of doing it this way is that we can see clearly the transformations of this function. You can see that if you compare this to the parent function, which is the reciprocal function, you can see that there's a vertical shift of 1 unit up, or vertical translation of 1 unit up, and a horizontal translation of 2 units to the right. So you can just think of this as a sketch of the reciprocal function with those translations and a vertical stretch by a factor of 3. Okay, so right away you can see what that would look like and have an idea of the sketch. But we're going to do some more investigation just to get some more clarification, okay? So first let's find out what the x-intercepts are. To find the x-intercept, you put y equals 0, or f of x equals to 0, and you get, you put this as equal to 0, you get x plus 1 equals to 0, so x equals negative 1. So that is the x-intercept. And to find the y-intercept, you put x equals 0. So you get y equals 0 plus 1 divided by 0 minus 1. So y equals negative 1/2 becomes your y-intercepts. The coordinates here are negative 1, 0, and here it's 0, negative half. Those are 2 points on the graph. We can see that there's a vertical asymptote here at x equals 2, so we can write that down. There is a vertical asymptote at x equals 2. And because the degree of the numerator and the denominator are the same, then you have the horizontal asymptote as the ratio of the leading coefficients. So coefficients in this case are 1 over 1, so y equals 1 over 1, which is 1. That's the equation of the horizontal asymptote. And to find, the intervals where the function is positive and negative, you're going to use a factor table, like we did in the last unit. So we know that the function, we can actually just go ahead and draw the asymptotes we have. So one is at y equals 1, which is right here, and the other one is at x equals 2, which is right here. We can write their equations, x equals 2 and y equals 1. And to get more points, we can use the factor table. So our key values are the parts where we have the x-intercept and where we have the breaks, which is at x equals 2. So we're going to use our key values at x equals negative 1 and x equals 2. And so we're going to take our fractal table from negative infinity to negative 1, and then from negative 1 to 2, and then from 2 to infinity. So we're going to draw intervals going from negative infinity to negative 1, and then from negative 1 to 2, and then from 2 to infinity. And look at what our function behaves like in those breaks. So we have x plus 1 as one factor, which is our numerator, and the denominator is x minus 2. And our function is x plus 1 divided by x minus 2. We can also take, test values. I didn't write that down, but maybe we can put it here. From negative infinity to negative 1, we can take a test value of negative 2. And from negative 1 to 2, we can take a test value of 0. And from 2 to infinity, we can take a test value of 3. And see what the signs are on our function, right? So if this was negative, this would be negative. If you put negative 2, this would be negative. You divide negative and negative, you get a positive. So our function is positive in this interval. If you put 0 here, this is positive. If you put 0 here, this is negative. If you divide it positive and negative, you get negative. If you put 3 here, you get a positive answer. If you put 3 here, you get a positive. You divide a positive and a positive, you get a positive. So you can see that the function is positive in this interval, negative in this interval, and positive again from 2 to infinity. So that kind of gives us an idea of where the function lies. Okay, so to find the positive intervals, it's going to be from negative infinity to negative 1, and from 2 to infinity. And to find the negative intervals, well, we just found that out to be from negative 1 to 2. And to find the intervals of increase and decrease, well, we know that the function, we can put some points that we have. So we have the x-intercept at x equals negative 1. So we have a point here. We have y-intercept at negative 0.5, which is here. And we know that our function is negative from mm, so it's going to be positive from negative infinity to negative 1 and 2 to infinity. So on this side also, we're going to have the function is positive. It's going to be approaching it like that. And here, it's going to be approaching it like that. So up till negative 1, it's above the x-axis, which is where it's positive. And then from negative 1 to 2, it's below the x-axis, so it's negative. And then here again, it's positive. If you want to get more clear points, you can put the value of the function at x equals, say, 4, 5, and 6 and get some clear points just to kind of get some idea of where it actually falls here. I just did a rough sketch on this side. Okay, so this is how you'd graph the sketch of this function, but you need to give some information before you do it. So to find the intervals where it's positive and negative, you can use the factor table. And if you look at the graph, this function is decreasing only. So it decreases only from negative infinity to 2 and from 2 to infinity. This we get from the graph. Okay. There's no intervals of increase. It's continuously decreasing as we go from left to right. Let's try another example. It's two of them actually. F of x equals x minus 3 divided by x plus 2, and another function g of x equals 2x plus 1 divided by x plus 3. Let's do the first one, the f of x one. And so we'll find for this one here, there is a, let's do the vertical asymptotes and the horizontal asymptotes. For here, this will be at x equals negative 2. The horizontal asymptotes we can tell by looking here, it's 1 over 1, so it's y equals 1. To find out the intercepts, the x-intercept, put y equals 0, and we get is at x equals 3. And the y-intercept, you put x equals 0, we get y equals negative 3 over 2. And when you do long division to find how you can rewrite this function, this would be f of x equals 1 minus 5 divided by x plus 2. So you can see that from the reciprocal function, it's shifted 2 units to the left and 1 unit up. And it also has a vertical reflection in the x-axis and a vertical stretch by a factor of 5. So those are some of the transformations you can see right away by looking at this. And we can also fill in positive and negative intervals and intervals of increase and decrease. The positive and negative intervals we can do by doing a factor table for this function, just to kind of see where it is at. So let's do a factor table, and let's use the key values, which are, we got the x-intercept, which is 3, and the vertical asymptote for this one was at x equals negative 2. So those are the values we're going to find in our factor table. So we're going to go from negative infinity to negative 2, then negative 2 to 3, and then from 3 to infinity. And we are going to take the numerator, the denominator, and then the numerator divided by the denominator, which is our function. For test values, -3, 0, and 4. So we put -3 here, this is negative, this is negative, so this is positive. Put 0 here, this is negative, positive, so this is negative. And you put 4 here, this is positive, positive, so this is positive. So you can see that our function is positive from -infinity to -2, and from 3 to infinity. And it's negative from -2 to 3. So let's do now the asymptotes. So there's one at y equals 1. There is a horizontal asymptote and a vertical asymptote at x equals -2. So that'll be going through here. Always write their equations next to them. X equals -2, y equals 1. And we have x-intercept at 3. We have y-intercept at -1.5, which is right here. And you can get some points on this side too, because this is the function is going to be, so it is positive from -2 to 3. So till here, it's going to be negative. From -2 till 3, it's below the x-axis, and then after that it goes above the x-axis. And then it's positive from 2 to infinity, and also 3 to infinity, and also -infinity to -2. So it's going to be above the x-axis on this side also. This is how the function will be on this side. Right? Now we can try the other one. And this one, you can see that when you go from left to right, the function is increasing. It's also increasing from left to right in this half. So it is increasing from -infinity to -2, and also from -2 to positive infinity. For the second function, our second function is 2x plus 1 divided by x plus 3. So we can say that the x-intercept is, when we put y equals 0, we get x equals -1/2. And to find the y-intercept, we put x equals 0 and we get y equals 1/3. So we have those 2 points. So it's -1/2 comma 0 and 0 comma 1/3. We have here, looking here, we can see that there is a vertical asymptote at x equals -3. And the horizontal asymptote, we divide the leading coefficients, we get 2/1, so y equals 2. And to find the intervals where it's positive and negative, we're going to do a factor table like we did here. So let's do that. And we're going to take our key points for this one as our x-intercept, which is -1/2, and our asymptote, which is -3. So it's -3 and -1/2. So we're going to go from -infinity to -3, then from -3 to -1/2, then from -1/2 to positive infinity. So those are going to be our intervals. Our test values, well, this can be -4. From -3 to -1/2, we could take, say, -2, and from -1/2 to infinity, we could take 0. And our function, the numerator is 2x plus 1, our denominator is x plus 3, and our function is 2x plus 1 divided by x plus 3. So you put -4 here, you get a negative. You put -4, you get negative. So when you divide two negatives, you get a positive. You put a -2 here, you get a negative. You put a -2 here, you get a positive. You divide a negative and a positive, you get a negative. You put 0 here, you get a positive. You put 0 here, you get a positive. You divide a positive and a positive, you get positive. So you can see that the functions is positive in the intervals from -infinity to -3 and from -1/2 to infinity. And it's negative in the intervals of -3 to -1/2. And we can now try to draw the sketch. Let's first draw the asymptotes. The horizontal asymptote is at y equals 2, which will be right here. And the vertical asymptote is x equals -3, which is this line here. We'll write their equations. X equals -3, and this one here is y equals +2. We can graph some of those points. X-intercept is -0.5, which is right here. And y-intercept is 1/3, which will be somewhere like here. And the function is positive from -infinity to -3. So it's going to be above the x-axis. So it's going to be like this. And on this side, it's going to be under the x-axis from -3 to this. It's below the x-axis here till -1/2, and then after that it's above. It's positive. Okay. And the function is increasing from left to right and also increasing from left to right in both of those parts. So there is only increase, no decrease for both of these functions. And so this one's from -infinity to -3 and from -3 to infinity. So that's the sketch of that function. Let's try one more example. Y equals -2x plus 1 divided by x plus 3. So the x-intercept, put y is equal to 0, and you get -2x, it will be equal to -1. So x equals 1/2. And to find the y-intercept, put x equals 0 here, and you get y equals 1/3. Do long division to get the expression for this. You'll get y equals 7 divided by x plus 3 minus 2. And then you can have an idea. It's going to be translated 2 units up, and it's going to be shifted 3 units to the left from the reciprocal function. So you can kind of have an idea now where the asymptotes are. The vertical asymptote, by looking here, is at x equals -3. The horizontal asymptote, when you divide -2 by 1, we get y equals -2. To find the positive and negative intervals, we're going to do the factor table. Our key values are going to be the x-intercept and the break that happens at x equals -2. So we're going to go from is it -3, and sorry, the other value is the vertical asymptote is at x equals -3, and the x-intercept is at x equals 1/2. So these two values. So we go from -3, so -infinity to -3. We'll start at -infinity to the leftmost value, which is -3. Then go from -3 to +1/2, then from 1/2 to infinity. And we take test values of -4, 0, and 1. And our numerator is negative 2x plus 1. Our denominator is x plus 3. And our function is negative 2x plus 1 divided by x plus 3. So you put negative 4 here, you get a positive. You get a negative 4, you get a negative. You divide these two, you get a negative. Put a 0 here, get a positive. You put a 0 here, you get a positive. You divide two positives, you get a positive. Put 1 here, you get a negative. Put 1 here, you get a positive. You divide these two, you get a negative. So the function is negative at these two intervals, which is negative infinity to negative 3, and from half to infinity. Those two intervals, that's below the x-axis, and it's positive from negative 3 to half. And let's now go ahead and draw the asymptotes. We have one at x equals negative 3, which is right here. Our horizontal one at y equals negative 2, which is right here. We write their equations. Y equals negative 2 and x equals negative 3. Plot the intercepts. X equals 1/2. And the y-intercept is at 1/3. Sorry, this is the x-intercept. X-intercept is right here. The y-intercept is right here. And you're going to find that this function is in this half and in this half. So it's going to be negative from half to infinity. So you're going to find that this part, it's negative. It's approaching like that. And from negative 3 to half, it's above the x-axis of this half, it's positive. And it's below here, so from negative infinity to negative 3, it's also this way. And you can see the function is decreasing from negative infinity to negative 3, and then from negative 3 to positive infinity. So it's only decreasing in both the intervals. Now, we've already finished this factor table. We can now practice on some questions.